Are you able to see the slide?
Yes, ma'am.
Okay. This is what we solved yesterday. The expression f is equal to ab plus cd. Now for this, whatever we have solved, now we have to draw the diagram. We have to draw the binary decision diagram. So that I will show you now. So now here, let me start with the root node A. Next, when I took A as two options are there. For A, we have 0 and we have 1. A, first we took f of A 0, f of A 1. So f of A 0, it is going to G of B. So this is nothing but B. And here you specify this is related to G. Okay, here you specify that this is related to G. This B is related to G for your reference. This is actually not required for your understanding, for your reference. You small this, I am writing it inside the box. It's not required. You have to write it inside the box. Just near to this node, small letters, you write G. And when A is 1, it is going to H of B. So once again, B only even here, but this B is related to H. This B is related to H. So you will be able to know this B is related to G of B and this B is related to H of B. Now what is happening to G of B? G of B also will have 0 and 1. H of B also will have 0 and 1. So G of B when it is 0, it is going to K of C. When it is 0, it is going to K of C. So here I will write inside this bracket C, and outside for reference you keep a K. So inside this I will write K. Next, B when it is 1, G of B when it is 1, G of B when it is 1 also it is going to same C only. So now what I will do, I will connect like this, same C. Okay. Next, H, when H is 0, it is again going to K of C only. So from 0, it is going to K of C only. Then H of B when it is 1, it is going to 1. It is going to 1. Next, here all it's hidden. So what is happening to K of C? When K of C is 0, it is going to 0. So when K of C is 0, it is going to 0. And when K of C is 1, it is going to D. So when K of C is 1, it is going to D. So here inside D, and this D is because of which variable, which alphabet? Because of L. Okay. Then this D, when it is 0, it is going to 0. When it is 0, it is going to 0. And when it is 1, it is going to 1. When it is 1, it is going to 1. So that's all we have drawn now. After drawing this, is it clear, students, how I have drawn? I'll repeat it once again. Shall I repeat, students? Are you all listening?
Yes, ma'am.
Shall I repeat? Is it clear? Any doubts there? As per this expression, whatever we did yesterday, I started from A, and A, we have two options, 0 and 1. When it is 0, it is going to G of B. When it is 0, it is going to G of B. When it is 1, it is going to H of B. And G of B, when it is 0, it is going to K of C. When it is 1, it is going to K of C. Okay. And H of B, when it is 0, it is going to K of C. When it is 1, it is going to 1. K of C, when it is 0, it is going to 0. When it is 1, it is going to D. Then L of D, when it is 0, going to 0. And when it is 1, it is going to 1. So as per this, I have drawn this graph. Next one step you need to do after drawing this graph or a tree. What you have to do is, you have to search for any redundant node. Is there is any redundant node in this diagram? Is there is any redundant node in this diagram?
B, ma'am.
B, ma'am.
B is only one redundant node because I have one input and we have two outputs going to the same node. So what we will do is we will remove this redundant node. We will remove this redundant node. I have removed the node. I have removed the output lines. Now I will connect this like this. So this will be the final binary decision diagram. Whether we got the same binary decision diagram previously, because same expression, very first expression we took this only, F is equal to AB plus CD, and we reduced directly using rules 1, 2, 3. Are we getting the same diagram? See, this is what? Look at this. This and this both are same. This also we discussed for the same expression, F is equal to AB plus CD. Now again, the same graph only we are getting. So now you have come across two different methods to reduce. If you are given with a binary decision tree, how to reduce it to the ROBDD or RBDD. One method is using the rules R1, R2, R3. Other method is using Shannon's expansion method. One more method we will go through, that is using reduce algorithm. Clear? Now let me take the same expression. Tell me what you guys have done in yesterday. One homework I gave no for Shannon's. What is that? F is equal to
AB plus BC
AB plus BC
plus AC.
plus AC. This is what I gave you yesterday. Correct? For Shannon's expansion, I asked you to do. Am I right,
Yes, ma'am.
students? Yeah. Now, F of A slash 0. What will happen to this expression when A is 0? We will get
BC, ma'am.
BC. So this is, let me consider G of, inside the bracket, which variable I should consider? B.
B.
Next, F of A slash 1. When A is 1, what you will get? B plus BC plus C. Anybody tried to simplify, or I can have to take as such only? Any possibility? A is 1, B plus BC plus C. Anything can I simplify this further?
B plus C.
B
ma'am.
plus
If I simplify, you will get B plus C. If you require, you can even simplify, not an issue. When I B plus C, we will get, right? So B plus C, this B plus C, this is first level. For the first level, here I am getting B plus C, here I am getting BC. Both are different. So definitely I have to assign two different variables. This is first level, F of A 0, f of a 1 is a first level. In first level, I'm getting two different expressions. So I have to assign two different variables. So I've assigned g and h, but with respect to b. Now let me take g of g of b slash 0. What is what we will get? G of b when b is 0, answer is 0. And similarly, g of b slash 1. What I will get when b is 1 in g of b, when b is 1, I will get only c.
C.
Next, h of b slash 0.
Ma'am,
When I yeah.
ma'am, for G of B for one C, ma'am, then we have to assign another K no.
But let me complete all the 4 in the second level. Then I
Okay.
will. Okay. Now h of b when you substitute b as 0, I will get c. Then h of b slash 1, what I will get when b is 1, it is 1, right? 1. Now in the second level out of 4, 0, 1, 1, I need to leave. I need not consider assign any variable there. If I look at this, these two variables are same. Let me assign the same variable there, k. Even here, let me assign k. And inside the bracket, it should be c. Inside the bracket, it should be c. Yeah.
Can I ask you one doubt?
Yeah.
When h of b equal to 1, it will be c, no?
H of b is b plus c. When I substitute b as 1, 1 plus c is 1 now.
Okay,
Okay.
ma'am.
Now, k of c slash 0 is equal to 0. K of c slash 1 is equal to 1 because k of c is just c. When c is 0, 0. When c is 1, 1. That's all right. So in the second level, we got k of c. In third level k of c, I didn't get any more expression, only 0, 1, 1. Have you done in this way? How many of them have got the same? Maybe variables might be different. Raise your hands. How many of you have done like this? Only this many? Raghuvamsi and all didn't do? I think so. Raghuvamsi didn't do.
Yes, ma'am.
Raghuvamsi, have you solved this yesterday? I asked you to do it, right? Whatever I've done now.
Ma'am, I was absent yesterday class, ma'am. I didn't attend.
Okay, at least now have you understood whatever I have done? Are you listening to the class?
Yes, ma'am. I'm writing each and everything.
Okay, you have to solve it, student. Please don't blankly look at the screen and sit. You have to solve. Only 34 have done. Remaining have not done. Prashant yesterday didn't join the class. Why? What happened to Jaswant? Why Jaswant you didn't go?
No, ma'am, I tried in the middle, but I didn't.
Okay. Sindhu Teja also didn't do. Sai Pranati didn't do. Sai Rohit, Raymond, Ujwala, Varun. What to do? Please listen to the class and whatever work I give, please do it. At least now understand and copy down these things in your notebook. Put your hands down. Those who have done, very good. I'm really happy. Others, please listen to the class. If you solve only, you will understand all these problems. Don't blankly listen. Parallelly try to solve it. Okay? Sri Navya, yesterday you were not there, right?
Yes, ma'am. Network issue, ma'am.
So now let me draw the diagram for this. Okay. So first A 0, this A is nothing but always it will be related to F, whatever the initial variable is given. Say F of A, when it is 0, it is going to be B. And when it is 1 also, it is going to be. Okay. And this is related to G of B. So G of B, when it is 0, it is going to 0. When G of B, when it is 1, it is going to C. K of C. This is K of C. When this is H of B. H of B, when it is 0, it is going to K of C. H of B, when it is 1, it is going to 1. It is going to 1. Next, this K of C, when it is 0, it is going to 0. K of C, when it is 1, it is going to 1. That's it, right? Is there any redundant node?
No, ma'am.
No redundant. Same problem. I think we didn't solve, right? Using R1, R2, R3. I think we solved for this. F is equal to A plus B into C. One more we will try. Same Shannon's expansion theorem. F is equal to A plus B into C. All the students, I will wait using Shannon's expansion. Last class we solved this. F is equal to A plus B into C using rule R1, R2, R3. We got this. Let us see whether we are getting the same answer. Let me check whether I'm getting the same answer. I'll keep it separately. Solve it. Everyone have to solve now. Nikita from B section. Nikita from B section. Are you there? Nikita is not there. Okay. Then Mahima. 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 Ujjwala.
Yes, ma'am.
Can you tell me what I have to write now here?
F of A by 0,
Okay.
A
Equal to
equal to BC.
BC. Equal to
G of B.
next.
F of A by 1
Hmm.
equal to C.
Hmm.
H of B.
Okay, Ujjwala. Next, Sahana. Sahana. Sahana.
Yes, ma'am.
Tell me.
F of,
F is done.
sorry, G of B by 0
Okay.
is equal to 0.
Okay.
G of B by 1
Hmm.
is equal to C,
Okay.
which is equal to H of C.
H. In this case, you need not again use H because this is at the next level you are getting the same expression. Okay,
Okay.
I think, wait. Yeah, okay, let it be. You tell me for H of B now. I'll tell you what to do there. What you are getting here, Sahana?
1 second. H of B by 0 is equal to 0. And
Then?
H of B by 1 is 1.
Okay. So now here it can't because same variable but it in the different level. So you have to assign different variable. Students listen. Yeah, this is in the first level and this is in the second level. Within the level only if you are, I think yesterday what we have seen, anything like that, whether we saw.
Ma'am, yesterday you told that we have to take from previous one.
Here, because here within the same level only I got. G and
Here.
H is same level. So I took the same variable. Okay, here we didn't come across anything like that. This is also in the same. This is also in the same level.
Yes, ma'am.
Here, the case is different. Here, this F is first level. F is first level. G and H is the second level. Okay, so let me assign a different variable. Maybe a S of C I will assign. But actually you will get the same answer. Let me see. For S of C also I will get the same thing. So now S of C is as 0 equal to 0. Then S of C slash 1 equal to 1. Okay. Now let me draw the diagram. So this is A. Next I will have B.
Ma'am,
Yeah.
for h of b given 1, we'll get C, no, ma'am.
Ma'am, h of b slash 0 also C, ma'am, only, ma'am.
Wait, I
X
didn't
of
check
B
that.
slash
What
B.
Sahana, what Sahana told it is wrong, huh? H of
B
yeah,
H of
given
b slash
correct,
0.
C,
correct,
C, ma'am.
correct.
H of b slash is C, ma'am.
This also C, right?
Yes, ma'am.
Both are C, ma'am. Both are C.
Both are C. So I can consider it as S of C, correct? Because all these are in the
Yes,
same level.
yes, ma'am.
Now it is right, huh?
Yes, ma'am.
Yes, ma'am.
Yes.
So this is because of G of B. And this is because of H of B. G of B, what happens? G of B, it is going to 0. G of B, it is going to 0. G of 1, it is going to G of 1. G of B of 1, it is going to C. This is going to C. This C is nothing but S of C. This is H of B. H of B when it is 0, H of B when it is 0, it is going to S of C. Check students whether I'm doing it correctly. Then
Yes, ma'am.
H of B when it is 1, it is going to same S of C. Okay. Then, yeah, this is S of C. S of C when it is 0, it is going to 0. S of C when it is 1, it is going to 1. It is going to 1. S of C. Now, completed, whether we completed all, this is G of B, 0 means 0, 1 means S of C. This is H of B, H of B when it is 0, S of C, when it is 1 also S of C. S of C when it is 0 to 0, when it is 1 to 1. Okay, what is happening here?
There
Any
is a
redundant node?
yes, ma'am. B.
Yes, ma'am.
This is
Leftmost
the,
B.
yeah, leftmost B is the redundant node. Let me remove it. Let me remove the output nodes. And let me connect it directly to this point. Is this and this diagram resembling the same?
Yes, ma'am.
Now is it clear, students, how to solve it using the rules R1, R2, R3 and using Shannon's expansion method? Yes?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, next we'll move on to reduce algorithm, third method. Next one is reduce algorithm. First one is using the rules R1, R2, R3. Second one is using Shannon's expansion method. Third one is using reduce algorithm. Okay. So now, just a minute. Now for the expression f is equal to, what is the very first diagram we have drawn? Okay, f is equal to AC plus BC. For that, now everybody draw the binary decision tree. I will also draw here. For the expression f is equal to AC plus BC. For this, everyone draw the binary decision tree. the first diagram without any reduction or anything. Okay, so using this reduce algorithm, let me tell you how to reduce that binary decision tree to ROBDD or RBDD or BDD. Okay, so first let me also draw the diagram. You also draw the diagram. How many variables are there in the expression?
3.
So how many leaf nodes will come?
8.
8 leaf nodes. You guys could have already completed. For me, it is taking time since I'm drawing like this. No other go online mode. Okay, almost done. Now tell me the values, pa, leaf node values. This one
0, 0,
0 0
0, 1,
0 0 0 1.
0,
Next
1,
0
0,
1
1.
0 1. Okay. Okay, this is the binary decision tree, what we are getting for a given Boolean expression. So now the question is, for the given expression, use the reduce algorithm, and draw the ROBDD or RBDD or BDD. Understand the question, students? Question is, for the given Boolean expression, use the reduce algorithm and get the or draw the final ROBDD or RBDD. Okay. Now let me explain you what you have to do using 1 minute, 1 minute. Yeah. Now let me tell you how you have to do. First take all the leaf nodes. Okay. First take all the leaf nodes. Now this is the leaf node or leaf node. Look at the value, what is present in the leaf node. As per that, you enter has 0. This first leaf node, the value inside the leaf node is 0. So I am writing has 0, that means number 0. Okay, so like this, you have to fill it for all the leaf nodes. For this leaf node, it is 0. The next one is also 0. Next one it is This will be 1. And next one, this is 0. And the next one, it will be 1. And for this it is 0. And for this it is 1. Okay. So first you have to start from the leaf node. As per the leaf node, what are the values present inside? You write has 0, number 0, number 0, number 0, number 1, number 0, number 1. This is number 0, number 1. Next go to the next node, next intermediate node, this node. Okay. If you look at this node for C, node C, this particular node C, the leaf node numbers are 0, 0. Leaf node numbers are all, both are 0 means the number for this intermediate node will be also 0. Now coming to the next C, here one of the leaf node is having 0, another leaf node is having 1. In that case, you take the maximum value is 1, 1 plus 1, 2. And next to C, if you see here, it has 0 and 1. Maximum value is 1. 1 plus 1, 1. Always the maximum value plus 1. For the next one, 0, 1. Maximum value is 1. 1 plus 1, 1. Sorry, 1 plus 1, 2. 2. Okay. Next, for the next intermediate node, B. Here for B, we have 0, 1, 2. Maximum is 2. 2 plus 1, 3. Next, for next to B, here both are same. Both are same. So, same value. Listen, is it clear, students? If the leaf node values are the next two participants, two values are same means same value. Whatever the same value. Both are having 1 means 1. Both are 0 means 0. Both are 3 means 3. If they are different, check for the maximum value, that plus 1. Now, what is the value for the root node A? What will be the value for root node A?
4.
4. Maximum value is 3. 3 plus 1, 4. So this is the first step you have to do now. Next, we need to analyze. Look at this and analyze. See, if I see this C, 0, 0, 0, all are 0. So I need not have all the 3. I can totally remove and connect this B directly to 1, 0. Okay, since all these 3 are 0, all are same, I can totally remove this and I connect this B dashed line to directly 1, 0. And next, if you look at this C, 2, 0, 1. This C also 2, 0, 1. This C also 2, 0, 1. So in that case, I can have all are same. 2, 0, 1, 2, 0, 1, 2, 0, 1, all are same. So I can, okay. So this is how we have to do.
Ma'am, your voice is breaking.
Your voice is
Voice
breaking.
is breaking. Am I audible now?
Yes, ma'am.
See now, is it clear now? Yeah, we have to. Yeah.
One dot, ma'am. How
Yeah.
you gave numbers as it hash 4, hash 3, hash 1? Can you repeat it once, ma'am?
Yeah, I'll repeat.
I
See,
couldn't
first, first you should look at the leaf node values. Okay, whatever value is present inside the leaf node, that will be the number for that leaf node. Clear, Gautam?
Yes, ma'am.
Next, like that I gave. This is 0, so has 0. This is 0, has 0. This is 1, so has 1. Like that I gave the number. Next, I went to the next level of nodes. This C, all the 4 C's are the next level of nodes. Now, looking at this C, if you look at this C, look at the 2 leaf nodes or 2 nodes below it. It can be a leaf node or a normal node or intermediate node, anything. Look at those 2 values. Both are 0. So, I will give 0. Here, if you see, both one is 0, one is 1. They are different. They are not the same. So if it is different, find out which value is highest. So among 0 and 1, 1 is the highest. So 1 plus 1, 2. So look at the values. If they are same, give the same value for that particular node. If the lower values are different, take the highest one and plus 1. So if you for this B, 0 and 2, highest is 2. 2 plus 1, 3. And in this case, 2 and 2, both are same. So same value 2. Clear, Gautam?
Yes, ma'am. Thank you, ma'am.
Yeah. So any other doubt, students? Is it clear? Is my voice audible now?
Yes, ma'am.
Yes, ma'am.
So now what I can do is this B, all are 0. Look at the number, all are 0. So if all are having the same value, I can totally remove it and connect it to one of the leaf node. So I can connect directly like this. And here 201, 201, 201, same pattern. So I can have only one C. So this will be C. And this is from here. And this is from this side. And this C, when it is 0, it is going to, when it is 0, it is going to 0. When it is 1, it is going to 1. Okay. Now, do we have a redundant node here? How I have drawn this diagram from this year is, mainly I was looking at the C level, last intermediate node level. I saw this pattern is 0, 0, 0. So I totally removed it. If all the three values are same, I can remove it. Same situation will come here. See, 2, 2, 2, 2, 2, 2. So in that case, I can remove this B node. I can directly connect. So in this case, I will totally remove this B. Otherwise also, if you look at that, you will understand this is a redundant node, correct? Wherever 3 values, you have to check, students. 2, 2, 2, same. So in that case, I need this B and 2 outlets. So this I can connect it to, and here also it is 201, 201, both are same. So I removed. I connected only once. Maybe this reduce algorithm, another 2-3 problems, if you solve only, you will understand, you will get different patterns. At least now, are you able to understand whatever I've done here with respect to this problem?
Yes, ma'am.
Yes, ma'am.
These are having 0. So I just considered only one leaf node. I've removed this as an, this is something like a redundant node if you are getting same values. Do you agree, students? One input and both the outputs are going to the same value. Correct?
Yes, ma'am.
Yes. If I'm getting the same values, same numbers, it is like a redundant node. So here C is redundant, B is redundant. So you can remove it. And if I look at this this 3C, it is 201, 201, 201, same pattern. So I can draw it only once. Maybe tomorrow we will try to solve another 2-3 problems and reduce algorithm. Okay. And I hope Xenons and the other method is clear for you. Correct? 2 problems yesterday I asked you to do it as a homework using rules R1, R2, R3. Are you were able to do it?
Yes, ma'am.
Yes. Vamsi Krishna, BVN, Vamsi Krishna, are you able to do?
Yes, ma'am. Yes, ma'am.
Okay, tomorrow let me solve another, we will solve another 2-3 problems and reduce, okay? reduce algorithm. Tomorrow, what time I told we can have mark?
1 o'clock.
1 o'clock, no? Okay. Any mock happened yesterday?
Today we are having.
Today you have. Or any other section you had yesterday? Am I audible? Is a problem with my voice?